Hello students, for class 10, today I am going to discuss on irrational numbers. Irrational numbers for class 10. Today is 17. Now, to prove whether a number is irrational number or rational number, first what we have to know. Let us explain that. Let P be any prime number if P divides a square. If P divides a square, then P divides A, where A is a positive integer. Okay, for example, 5 is a prime number, divides 2 to 5, which is equal to 15 square. Implies 5 divides 15, which is true. Therefore, the above statement, it is. So it is proved that whenever the prime number 5 divides 2 to 5, the square of 15, it divides 15 also. Match. P is a prime number, divides a square, P divides a. This is true. Now, suppose we are going to prove that root 2 is irrational. So let us write down one question. So that root 2 is irrational. Root 2 is irrational. Means irrational number. These are actually contradictory proof. We have to prove that root 2 is irrational. What we will suppose just the opposite of this. Let us assume that its solution, you see. Let us assume that root 2 is a rational number. A rational number. Now what we know, every rational number can be written in the form of P by Q, where P and Q are co-prime integers and Q not equal to 0. Therefore, this implies that root 2 is equal to P by Q, where P and Q are co-prime integers and Q not equal to 0. Now squaring. Now squaring, what will we get? 2 is equal to P square by Q square. This implies 2Q square is equal to P square. Now, since 2 is a factor of P square, this implies that 2 divides P square, implies 2 divides P. Okay. Now, as 2 divides P, so we can write, let whenever P is divided by 2, we get M. So P is equal to 2M, implies P square is equal to 4M square. Now, if we say this is equation 1, then from equation 1, we can write P square means 4M square, that is 2Q square is equal to 4M square, implies Q square is equal to 2M square. This is 2. This implies 2 divides Q square. Q square implies 2 divides Q. So what we get? 2 divides P, 2 divides Q. So 2 is a common factor of both P and Q. Hence, P and Q have a common factor 2. This contradicts the fact that P and Q co-prime. This implies our assumption is incorrect. This implies that root 2 is not a rational number. This implies that root 2 is irrational number. Now students, remember one thing, whenever these proofs come in the exam, actually these proofs are very common for the board exam, you have to follow exactly the same answer as I have written. So in the same way, you can prove root 3, root 5, root 6, root 7, root 10, all these are irrational numbers except the perfect square numbers are leaving the perfect square numbers. Okay. Next, another type of suppose we have to prove that 2 minus 3 root 5 is an irrational number, so that two minus 3 root 5 is an irrational number. Now here one thing the student must know, what is the meaning of this question? It means that it is accepted, remember, that root 5 is irrational. Then your question is, if root 5 is irrational, is it that 2 minus 3 root 5 is also irrational? 3 plus 2 root 5 is also irrational? Like this and that. So how to do the proof? Again, in the same way we will write, let its solution, you see, let 2 minus 3 root 5 be a rational number. Then rational number means it can be expressed in the form of p by q, where q not equal to 0 and p and q are co-prime integers, as you know. Therefore, we can write 2 minus 3 root 5 is equal to p by q, where q not equal to 0, p and q are co-prime integers. Co-prime integers. Okay? Then this implies that 3 root 5 is equal to 2 minus p by q. That is equal to 2q minus p by q. This implies root 5 is equal to 2q minus p by 3q. Okay. Now let us consider the right hand side. Consider RHS, means right hand side. What is that? 2q minus p by 3q. As p and q are integers, therefore right hand side is equal to rational number. Is this clear? If not clear, you listen again. In the right hand side, what we have seen, 2q, p and 3q. You know that 2 and 3, these are already integers, you know. What we have supposed that p and q are integers. So p and q are integers. Now operation of integers gives rational number. So right hand side rational number, which implies that root 5 is equal to what? This right hand side, that is rational number. Rational number. But in the beginning I have told you the meaning of this question is that it is accepted root 5 is irrational. Then you have to justify whether 2 minus 3 root 5 will be rational or irrational. Clear? So what comes? Root 5 is a rational number. But what is accepted? Root 5 is irrational number. Okay? But root 5 is an irrational number. Then what happens? Our assumption is incorrect. Implies our assumption is incorrect. Which implies that 2 minus 3 root 5 is not a rational number. Which implies that 2 minus 3 root 5 is irrational number. So, whenever the numbers are given of this type, writing pattern will be the same. Writing pattern will be the same. Now suppose I am showing you one more. Suppose you are given that so that 3 root 5 is an irrational number. Now this time 2 minus this part is not there, it is only this. Here also, first to clarify the meaning. The meaning of the question is that it is accepted root 5 is irrational. Then you have to give the justification whether 3 root 5 is rational or irrational. Clear? Rational or irrational. So let us make the solution. Show solution for this one. Let 3 root 5 be a, as we have written, rational number. So what is this? This is our assumption. So what is this? This is our assumption. As 3 root 5 is the rational number, it can be written in the form P by Q. Then, so let us write 3 root 5 is equal to P by Q. Q not equal to 0. P and Q are co-prime integers. P and Q are co-prime integers. Clear, students? Okay. Then this implies that root 5 is equal to P by 3Q. Now consider right hand side P by 3Q. Now what you know, P and Q being integers, P by 3Q is rational number, is equal to rational number. Write the reason as P and Q are integers. Therefore, what you get? Root 5 is equal to rational number. Rational number. This implies our assumption is, but what you know? We know that root 5 is equal to rational number, but we know root 5 is irrational. This implies our assumption is incorrect. This implies 3 root 5 is not rational. This implies 3 root 5 is an irrational number. Irrational number. All these statements you need to write exactly the same way. Don't deviate from the writings. Your answer will be wrong then. Okay, students. Then I am going to discuss on whether a decimal will be terminating decimal or non-terminating decimal. How to judge? Let us discuss this one through one example. Suppose you are given a rational number. A rational number the decimal expansion of rational number will be of two types: terminating decimal and non-terminating but repeating decimal. Non-terminating, repeating decimal. Okay. For example, suppose we are given 23 by 315. Suppose we are given. Without long division, that is without actual division, we have to determine whether the rational number will be terminating or non-terminating. For terminating decimal, as it is the rational number, both the numbers can be expressed in the form of P by Q. So for this number, denominator Q can be written in the form 2 to the power m into 5 to the power n. Whenever the rational number is in the least fraction form. Now least fraction form means no more cancelling will be possible. So first we have to see whether cancelling is possible or not. If cancelling is possible, you have to do the cancelling, otherwise answer will come wrong. And for this type of denominator, Q cannot be written in the form of 2 to the power m into 5 to the power n. Now what is the meaning that Q can be written in the form of 2 to the power n and 5 to the power n and cannot be written in this form? If it is written in the form, it means number 1, denominator contains the factor only 2 or 5 or both 2 and 5. No other factors except 2, 5, both 2 and 5 will be there. Now what is the meaning of that? q cannot be written, denominator q cannot be written in the form of 2 to the power m into 5 to the power n. It means denominator contains factors other than other than 2 or 5. Like 2 may be there, may not be there, 5 may be there, may not be there, but or both may be there, may not be there, but there must be other factors like 3, 7, 11, 13, 17, like that. Other factors will be there. So if there are other factors, then they will be non-terminating but repeating, that is recurring number. For example, what we have taken? We have taken 23 by say 315. So let x is equal to 23 by 315. Okay, 23 by 315. First let us see, is cancelling possible? So 31, 23. First let us see if this number is divisible by 23. So 23 1 is 23. Then 31 minus 23, 8, 85. 85 is not divisible by 23. So no more cancelling is possible. Now let us find out the factors of 315, prime factors of course. 5, 5, 6, 30, 5, 3, 15, 3, 3, 2, 6, 3, 1, 3, 3, 7, 7, 1. So the number can be written 23 by x is equal to 23 by 3 into 3 into 5 into 7. Now you see the denominator contains factors other than 2 or 5, that is 3, 3, 7, like that. It means therefore q cannot be written in the form of 2 to the power m into 5 to the power n. We need to write. Hence x is equal to what? This form. Means non-terminating but repeating. X is non-terminating but repeating decimal. If the rational number is converted to its what? That is to its decimal form. Now, without actual division, we also can write the decimal position of the number. For example, I am taking one example, say 43 by 2 to the power 4 into 5 to the power 3. If it is a terminating decimal, then how many places after decimal point will occur? We have to show. So this is equal to what we see, it is equal to P by Q. So obviously Q is equal to 2 to the power 4 into 5 to the power 3. What are the factors? 2 and 5. So Q can be written in the form 2 to the power m into 5 to the power n. Hence, 43 by 2 to the power 4 into 5 to the power 3 is a terminating decimal. Now what we have to do? We need to find the place of decimal. Now for place of decimal, 43 by 2 to the power 4 into 5 to the power 3, that is, we need to write 2 and 5 with the same power, and that has the bigger power. Bigger power is 4 of 2, so 5 to be written in the power of 4. So we can write this one as 43 into 5 by 2 to the power 4 into 5 to the power 4. That is equal to 5 3 15, 5 carry 1, 5 4 20, 21. 215 by 10 to the power 4. So in lower classes you all have learned that 10 to the power 4 means decimal point will occur, that is, it will terminate after 4 places of decimal. Hence, it will terminate after 4 places of decimal. Four places of decimal. Therefore, what will be the decimal expression for the number? There is x is equal to, now 4 places of decimal means 2, 1, 5, 4 plus 1, 2, 3, put 0, it is 1. So 0.0215, it will be the decimal expansion of this one. If you want to judge, you have your calculator, there you divide this number, you will get this. So without long division we are able to write, to judge whether the rational number is terminating or non-terminating. If it is terminating without long division, we are able to discuss after how many places the decimal point will occur. Okay students, up to this for today. Now you will get some works. There is one worksheet containing some sums regarding this discussion. Okay, thank you.